Agata.
Sir, Edric is writing my.
Hello. Good morning to all.
Good morning, sir.
Morning, sir.
Good morning, sir.
Very good morning.
Good morning, sir.
Good morning, sir.
Good morning. Good morning, Ira, David, Miracle, everyone. Good morning. How are you doing?
Good.
Good. Okay. So yeah. So you guys gave test. I think we have a lot of tests. So I will check this test by today. Not today. Saturday only I have time. So I will check it. And what chapter we were doing? The last part of that, and today we'll start the new chapter also.
Sir,
Yeah,
maths, right?
yeah. What chapter we were doing? 17. So in the previous class, we learned about the uh, alternative segment theorem. Yes, David, turn on your camera, please. So in the alternative segment theorem, what we learned, for example, this is a circle, and if I draw a tangent to this circle, before tangent, if I will draw the chord, and the same chord makes the angle on the circumference like this figure. Everyone got this? Okay, if I will write the name on this, so it is A, B, C, and then the line D. This is A. So, what this theorem says that the CB is the chord, yes, and it makes the angle with tangent AD, not AD, ED. Okay. CB is a chord which makes the angle with tangent ED, and the same chord makes the angle on the circumference. So these two angles are equal. That we learn in the alternative segment theorem. Everyone got this?
Yes, sir.
Yes or no? So in this we can conclude that BCD is equals to angle BAC. This one is equals to this one. Any other observation that we can get? We can get that this angle ACE is equals to angle this, which is angle ABC. So we can conclude both of this from the alternative segment theorem. This was what? Alternate segment alternate segment theorem.
That means angle uh, BAC plus angle ABC equals 180, right?
B, A, C, and
ABC.
no, it won't.
But if this is equal to this and this is equal to this, then according to linear pair, ACE plus BCD is 180. Same
But
way,
this angle ACB, how will you find the ACB? Like this angle is equals to this angle is equals to this, but this part is not there, na? Then how will you conclude that it's a 180 degree? like it's a straight line. This angle plus this angle plus this angle, this all will make 180 degree, no?
Yes.
So like this angle is this, correct? This angle is this, but the middle part is still unknown, no? So we can conclude like this plus this is 180, like it's a triangle. It can be. Or we can conclude that this plus this is also 180. Why? Because it's a linear pair.
Oh yeah.
Got,
Yeah. I forgot.
got it?
Got it.
Okay. So now we'll do some questions based on it. Okay. So are you guys writing this?
Wait, sir. I'll write it now.
Hmm.
I was absent because I had a PCP PCPP PCP practical. Oh, it's all
Okay.
because of data entry. It's all because of data entry. So
After this, what chapter we have in
uh,
maths?
angles in a circle and cyclic quadrilateral. Chapter 16.
Okay.
Wait. Alternate segment theorem. Desuran Argha. Desuran.
Okay, guys. So we have this question. Okay. What they are asking? They are asking APX. What is APX? This is the APX. This is APX. Okay. That they are asking, and they are asking BPY. BPY. PPY. So we have this question. Okay. They are asking these two angles. So what they are asking to find angle APX and angle BPY. These two angles we have to find. Okay, these two angles we have to find. Okay, now everyone please pay attention because one theorem is there which we don't learn because it was a part of TMA. I guess TMA or the next chapter that we have, maybe that come in that also. But still we can learn this. Okay. So this theorem says that, okay, this theorem says that if a chord makes angle on the center will be the double if same chord makes makes angle on the circumference Okay, we have this thing. Okay, let me understand this. So I will not write here. Instead of that, shift it to another side. Okay, we'll come to this now. So this theorem says that if a chord makes an angle on the center, will be double if the same chord makes the angle on the circumference. Okay, everyone please pay attention. This theorem is important theorem. Okay, for example, we have this circle in our midst. Okay, correct. Okay, and we have this chord, and this is the center. Okay, so we have this chord in which, like, this is A, this is B, this is O, and this is D. Okay, so we have this structure. Everyone, please pay attention. I will make you guys understand this thing. Okay, so for example, we have this like this chord. Can you check this chord? Which chord I'm asking? AB is the chord, and it makes the angle in the center. Okay, and the same AB chord makes the angle on the circumference. Are you getting this, Agatha? Yes, I'm repeating it this again. AB is the chord,
Yes.
makes the angle on the center.
Yes.
And the same AB is the chord which makes the angle on the circumference.
So that means
So
the angle at the center is double that angle of the circumference.
circumference, correct. For example, if this is a 30 degree, then this will become
15.
15 degree. Because the theorem says this only, the angle created by or subtended by the chord at the center will be double if the same chord makes the angle on the circumference. So circumference angle will be the double of the center angle.
Sir, I don't
Everyone-
understand.
Yeah.
I don't understand how does the chord also is somehow related to the circumference. I mean, makes an angle on the circumference.
See, this D angle is arises from which chord? It's arising from the AB chord, na?
Yeah,
So, and this O, the center angle is arises from which chord?
AB chord.
So from that we can conclude that AB is making same chord on the same angle on the circumference and same angle on the on this center.
Then what do they mean by circumference?
Circumference. This is circumference, the outer covering of a circle. The outer covering of a circle is called a circumference. The chord is making angle on the circumference.
You mean like the triangle ADB is connected to the circumference. So like that we say
Yeah.
the chord is making angle on the circumference.
Yeah.
Okay.
Now write it down this thing.
That if a chord makes angle.
So what this theorem is trying to say is that AD if a common chord, I mean like AB can make two angles, ADB and A okay. There's a chord AB and AB makes two angles, AOB, ABO and ADB. Now AOB will be I mean like ADB would be double of AOB.
No, you are saying opposite. The
Oh
A,
yeah.
AOB. Agatha, AOB would be double of ADB.
Yeah, okay.
So, for example, we'll take one more example.
What is the theorem called?
What, beta?
What is the theorem called? Name of the theorem.
What is it? It's not, there's no name. It's like just statement. It's angle subtended by a chord. We can put as a headline, not the name also. Okay. So what will the angle on the circumference? The ADB angle will be? Tell me, guys.
30 degrees, sir.
Yeah, the half of it. Now, everyone, please pay attention. One more thing that we are going to learn. Now, for example, this is one more angle created by the AB chord, and the name of this angle is angle AEB. Now, you guys tell me, what will be the AEB? What will be the AEB? Anybody?
Will
Give
it
it
also
a
be 30?
yes, it will be 30 because the same angle,
E is
same
on the
chord makes the
circumference.
angle.
Because E is
Yeah,
on the circumference.
same chord makes the angle on the circumference. That is correct. So we can conclude this. We can conclude one more theorem regarding this, and this theorem says that if a chord makes angle on the circumference, no, if the chord makes angles, I'm saying angles on the circumference, then all the angles on the circumference will be equal, no matter how many angles are there. Same chord should be there. So from this, we can conclude that, for example, if I will write A, B, C, D, and this is a circle, like O, which is center of circle. So we can conclude that BAC is equals to angle BDC. We can say that. Like we have this 30 and this 30, na? Because the same chord is making angle. In the same way, this angle and this angle is also equal because the same chord making the angle. So I will write the statement. Everyone got this?
Yes.
Yes, sir.
Sir, but when will all of this circle theorem actually becomes helpful?
Helpful or
I mean, like applications.
application you guys will get when you will do architect and all, I believe.
Done, sir.
Okay. Now we'll do this question. Okay. So we have this question, and it is given that angle AOB is a diameter, like AOB is a diameter, no? Why diameter? Because it is going to the center. So, so we can say that here in this question, AB is a diameter. So I will ask this question from everyone. Like Edric, if you know, just let everyone do. Then if they don't know, then you say, okay. So this AB is the diameter. So tell me this angle, ACB. What will be angle ACB?
$90.
Okay, 90 degree. Anybody else?
So 90.
90. Okay. Ira, want to give a try?
Yeah, I'm thinking, sir. I'm not sure.
Yeah.
So total angles made in the triangle is 180, right?
Yeah. Yes.
So maybe 60.
Okay, 60
No.
degree.
Okay,
Okay.
maybe not 60 much. Maybe 30 around.
Okay, 30. Okay.
Ah,
Melanie, you want to give a
Yeah,
try?
sir. I was also thinking that it could be 30.
Okay.
I don't think it is 90. But
Okay. Edric,
sir, it's 90.
90. Okay. David, why 90?
Uh,
Why you say 90?
so I don't know. I just thought of 90 because AOB is 180, I guess. I'm not sure.
Okay, you are very near to the answer, but not the perfect answer. It is a good answer, but not a perfect answer. Just why 90?
Because AOB is the longest chord, and it's not possible for any other of the things to be longer. And in a right angle triangle, the hypotenuse is the longest side of the triangle.
Wow, this reason is correct, and but I observed this first time. Very good. Okay, so yeah, Jashron's reason is correct. Okay,
Like,
but
sir, what is the meaning of her reason?
see, in a circle, the diameter is the longest. In a circle, the diameter is the longest, no?
Yeah.
And ACB is a triangle. Is a triangle.
Yes.
So in that triangle, the AB is the longest chord, and the longest chord can only be formed when we get 90 degree, like hypotenuse h square is equals to p square plus b square, no?
The
H
longest
square,
chord can only be made with a 90 degree.
yeah, because the h square is equals to p square plus b square. In the right angle triangle, the hypotenuse is the longest one. So yeah, we need to do technically in that part. But what I'm trying to say that in this, what is the correct answer is, Edric, want to give a try? Why?
Wait. ACB is 90 and okay, so since CO is perpendicular to AB over here, so if CO is perpendicular to AB, then CAB and CBA are 45 each.
No. I'm asking why ACB is 90. That question is my question.
That's not that. What can you answer it?
ACB is 90.
Why? Why it's 90? No idea?
hmm. ACB is 90 with AB.
The ACB is 90, that is correct. It is correct. But why? Okay. So we know that this is a diameter and it's a straight line. Yes?
Mhm.
And the AB is diameter as well as chord. Now AB is a chord and it's subtending because straight line subtends the angle 180 degree. 180 degree or not? And the same AB chord is making angle on the circumference. So it become the half of it.
Oh, ho, ho, ho.
And 180 half is 90.
So it's passing through the center of the circle. So which makes it 180 and passes the center of the line passes the center of the circle, then on the circumference it will always be 90. So he's saying that.
Yeah,
And
because half of it.
and even at any point in the circumference, it will still be 90, right? Any point in the circumference.
Yeah, any point. For example, if I
So
will
if a
make
triangle is made with, so if a triangle is made by the chord if you make a triangle which
Hmm,
touches the circumference on the diameter, it is always going to be 90 degree.
yeah, okay. Okay. Now we'll come to this question. Now you guys will do this question. Now I will not do.
Which question?
Right. Now you guys try.
So which question?
We have this example 17.8 in our mid- Right, right. Okay, done.
Wait. Wait. Not yet, sir. Done, sir.
Everyone got this?
Yes, sir. But I did a different method. First, like I took a PABS 40 and APBS 90. So in the triangle, no, I use the angle sum property for triangle to find the angle PBA, which is equal to angle APX. So I PAB plus ABB plus PBA 180, and I got PBA as 50. So I got APX as 50 and BBY as 40.
Correct. No problem in that. But yeah, anyone has doubt in this question? Ask me.
No, sir.
Agatha?
Like how did 40-degree come? How did PBY become 40-degree in alternate segment theorem?
Okay, so now tell me which chord is making angle on the circumference, like APY.
AB. No. It's APB, right? No, I
Yeah,
mean AB.
no. Chord is there. Yeah, okay, just give me a second. So I'm saying the PB chord makes the angle APAB, which is on the circumference, and the tangent makes same angle with the like angle with the same chord PB. So it means that this angle and this angle both are equal. Understood? This angle will become the half, which is 90,
Yeah.
and this angle both are equal. So when I get 90, I will add all this number to get the linear pair, because linear pair says that in a straight line the angles are equals to 180 degree. So it will be 180 degree. Can I solve it? Got it? Miracle?
I
Yes, sir.
mean, I
Yes.
don't understand the alternate segment one.
Okay. See, we have this tangent. Yes. And we have this PB chord.
I is tangent.
Yes. The PB chord is there.
Yes, PB.
Agatha.
Yeah.
And the same PB chord makes the angle on the circumference, this one.
Yes.
And the same chord will have an angle with the tangent. The thing is, it should be the same chord. It shouldn't be the different chord. Like I can't say that this angle and this angle are equal. Like because this is AP chord making the angle with the tangent, and this is the AP chord which are not making the angle on the circumference. It will be this much. This and this will be equal, and this will be equal.
So then why isn't XPA and APB equal?
XPA and
APB.
APB. Where I wrote?
APB is 90-degree.
Yeah, where I wrote it's equal. Like this and this are not equal. No.
Okay.
XPA can't be 90. If XPA is 90 means the 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 line XPY will not be 180, it will be 220.
Yeah. Okay, we'll do this question also. Okay, guys, listen now. We have this thing in which we know that AB is equals to AC. Okay, it is given that AB is equals to AC. Now we have to show that the XY is parallel to the base BC. That we have to show. We have to show that XY is equals to BC. Okay. Now everyone please pay attention. Okay. Listen, guys. Listen, everyone on the board, please. Okay, we know that and like AB is equals to AC. Okay, what we know that AB is equals to AC, and from that we can conclude that triangle ABC is an isosceles triangle. Okay, what is isosceles triangle? Isosceles triangle is a triangle in which two sides are equal, and the isosceles triangle has a property that we are learning from our childhood times, that in an isosceles triangle, the opposite angles of the opposite sides are equal. For example, everyone please pay attention. This is a side, and what is the opposite of it? This one. And this is the side which are equal to this side. And what is the opposite angle? This one. So this is a property of a isosceles triangle, that opposite angles to the opposite sides, to the opposite equal sides, are equal. So we can conclude that angle ABC is equals to angle ACB. Why? Because isosceles. So you guys have to write everything, okay, what I'm writing in the exams also. If you're not writing this thing, you will not get full marks. So isosceles triangle.
But sir, like, do we need to draw the diagram in exam?
Yes, of course.
Are
Okay. So we have this thing. Okay, now I will write this angle 1 and this is angle 2. Now I will ask this question from Agatha. Agatha, uh, uh, is angle 2 is equal to anything? She freezes, I guess network bad. Okay, David, tell me, this angle is equals to anything?
Angle 1, sir.
Yeah, that is correct. Another thing, another angle.
No, sir, I don't know.
I know.
Alternative segment theorem.
I know.
Yeah,
So it would be AX, it would be equal to.
Yeah,
BAX. Good.
Yeah.
So it means that this angle is equals to this angle, which is angle 3, because of alternative segment theorem. Everyone got it?
Yes, sir.
So it means that angle ACB is equals to angle XAB. Why? Because of alternate segment theorem. Okay, so now from that, like, this is like, if I will write in a angle waveform, so in this we are saying that angle 1 is equals to angle 2, and in this we are saying that angle 2 is equals to angle 3. So this is first and this is second. So from first and second, what we can conclude? From first and second, what we can conclude? We can conclude that angle 1 is equals to angle 3. Why? How? See, 1 is equals to 2, 2 is equals to 3. So it means that they both are equal. Yes or no? Miracle, got it?
Sir, so angle ABC angle ACB, angle BAX, and angle CAY are all equal.
Yeah,
Okay.
in this case only. In this case only. Not in every case. Okay. Now, is it forming Z like this? This is equal to this. So it means that it is forming like Z, and Z is the property of alternative interior angle. Like what the alternative interior angle says that if two lines are parallel, then their interior angles are equal. This is the property of alternative interior angle. So it is forming Z. Z shows that like these two angles are equal. So it means that XY is parallel to BC. So from first and three, we the above relation shows alternate interior angle. Hence, BC is parallel to XY. Everyone got this?
Wait. ABC, wait. AB is equals AC.
Okay. Now you guys have 3 minutes break, then come back. We will do the work and energy part. Come back in 3 minutes quickly.
Okay, sir.
Okay, guys, come back.
Sir,
Yeah,
are we done with maths chapter?
yeah, that chapter we have completed, and then Monday onwards we will start a new chapter.
Now, work and energy also, do you think we can finish today?
I believe we can, but no, we can't, because base energy transformation is also there. Okay, now everyone, please pay attention. Okay, so we have mechanical energy. So we learned that whatever the work which we do, it convert into the energy form. Okay, so the work that we do, it's converted into the energy form. So now first energy that we're gonna learn, it's called as mechanical energy. Which energy? Mechanical energy. Now what do you mean by mechanical energy? Okay, the mechanical energy is the energy, it's the work that we do by a body. Okay, so basically, okay, everyone please pay attention. Now, this is a this thing, what? Capo, guitar capo. Okay, if I will leave it, okay, what will happen? If I will drop it, what will happen? It will go downward, it will fall. Okay, now if I will take it to the one higher position, then also it will fall. If I will go to the building top high, and then if I will let him fall, then what will happen?
It will break.
It will break. So it is breaking. Yes, it's breaking. And it is, if it is breaking, then it means that some energy he should have. That's why it's breaking. Like if I will put it on the desk, it's not breaking. Like automatically it won't break. But if I will take it to the some height and make it fall from the high building, then what will happen? It will break. It means that it has some energy. Okay, that energy is called as mechanical energy, because we changes the position. It was on the desk, but we changes the position to the topmost high of a building. Okay, the position changes, and because of that position changes, it possesses some energy, and that energy makes it to break. Okay, for example, we'll take one more example. Now, for example, this is a nail, okay, and this is a hammer. Okay, everyone, please pay attention. Now, whenever we nail the hammer, no, whenever we hammer the nail, then what will happen? We do like this, or we do like this. How we do? We have to hit the nail hardly, like this, so that the nail can go inside. If you will do like this, oh baby, please go inside, go inside, it won't go. It won't go. Why it won't go? Because it needs energy. So when you are changing the position of a hammer, okay, because of that, it is going inside. The nail is going inside. That is called as the energy. Okay, that is called the energy. We'll take one more example, like a bow. Bow. Okay, so the bow is like normal. It's like this. Okay, but now I am doing some work. I am doing some work. Okay, and when I did some work, the work is converted into the energy in this arrow. When I will leave it, the arrow will move. The arrow will move. Okay, and because the arrow is moving, it has some energy that is called as mechanical energy.
So
So
mechanical energy is basically work, right?
it's a work that we do or that a motor do. Okay, because of that, the work is done, and the energy is transformed into, like, the work which we do, it is transformed in the form of energy. One more thing we can say, like everyone has a tank, water tank. Okay, like in your house there might be a water tank. Is it downstairs or it's upstairs, like in the roof? In the roof,
Upstairs.
yeah. So means like what, like you guys will have motor also which pump the water to the up roof tank. Yes. Okay, now motor did some work. That work now the water has, the energy the water has. When you will open the tap, because of that energy, the water is moving into the pipe through the tap. Got it?
Yes, sir.
So mechanical energy, this is the capacity of doing work that a body possesses by virtue of its position. Means because of the change in position, their energy changes, and virtue of the motion. Okay, everyone please pay attention. Now, mechanical energy has two parts. First is potential energy, and the second one is kinetic energy. Potential energy and kinetic energy. Okay, now we'll understand it. So we
Sir,
have, yes,
so mechanical energy is just the result of the work.
yeah, yes,
Okay.
you can say that. Okay, now listen. Okay. So for example, we have this thing. Okay. Now, what is the potential energy when object is at rest and the position changes? Okay, now listen. I took this capo and I took it to the most high building. Okay. So what like I did some work. Now the I'm about to drop it. Till the drop position, it is at rest. Like I'm just holding it, it is at rest. When I will drop it, then what will happen? It will move. So the energy is basically when I'm holding it, it is having a potential energy. It is having a potential energy. Why? How the potential energy came? Because I did some work to raise this object to a height. So the work which I did to raise the object to a height, that makes the object possess with the potential energy because it is at rest. But when I will leave, like when I will drop it, now, ouch. Now when I will drop it, it is in moving, it is in motion. So now in that case, the potential energy is transforming into the kinetic energy. Got it, everyone? Or shall I explain one more time? I am taking to the high, having this potential energy because it is at rest. When I will drop it, the object is in motion, and the motion is basically the kinetic energy. And in that, the potential energy is transforming into the kinetic energy. And in the whole scenario, the mechanical energy will remain constant. Means everyone, we can pay attention like this. Please pay attention. For example, we have this object at height. This is the capital H at height. Now, because I didn't drop it, it has maximum potential energy. Why maximum? Because I am just holding it. It's not moving and it has rest. Okay. So, and in this kinetic energy will be 0 because it's not moving. Okay. Kinetic energy is the energy when an object possesses when it is in the motion, when it is moving. Okay. Now, if I will calculate the mechanical energy is equals to the potential energy. Why? Why it's so? Because mechanical energy is equals to potential energy plus kinetic energy. Yes. Somebody saying something? Okay. So in this case, the kinetic energy is zero. That is why the mechanical energy is equals to potential energy. The first case. This is A part. Okay. Did you understand? Now in this, now when I will drop it, it will come to the mid part. This is B. Now in this case, the potential energy is reducing and the kinetic energy is increasing. But like it will be like that. Like for example, in the starting, the mechanical energy is 5. Okay, it's 5. Now in the B part, the potential energy will become 2.5 and the kinetic energy will also become 2.5. So the mechanical energy will always become a same value. Are you getting my point? No. We'll take one example. Everyone, please pay attention. I will take everyone doubts. Just give me a second. For example, in the A part, the potential energy is 5 joule and this is 0. So in this case, mechanical energy is 0. No, not 0, 5. 5 joule. Everyone got this? Okay. Yes. Now, in the B part, it will be like that. The potential energy will decreases and become 2.5 joule. And the kinetic also will become increases to become 2.5 joule. Okay. And the mechanical energy in this case also it will become 5 joule. Same as the starting point. And when it is just about touching the ground, in this case, the potential energy will become 0 and the kinetic energy will become the maximum like 5 joule. So in the last C part also, the mechanical energy is 5 joule. So what I'm trying to say, in each case, the mechanical energy remain constant. It won't change. Like 5 joule, it will be remain 5 joule. It won't go 6 joule, 8 joule, or 4 joule, or 3 joule. No, it will remain 5 joule. Got it? Yes, Agatha.
So what's the difference between potential energy and the mechanic and the energy?
Kinetic. So the
Kinetic.
difference between kinetic and potential energy, for example, you are stretching a bow. Okay, you are stretching a bow. You are doing work. You are holding the arrow and you are just doing like this. Now, when you are holding it right now, you are holding it. Okay, so it means that right now the arrow has some energy because you are doing some work. Okay, at rest, it's there. It is called as potential energy. It has a lot of potential energy. Okay, but when you leave it, then what will happen? The arrow will go straight. So the arrow become in motion. It is called as kinetic energy.
So kinetic energy is moving energy, and potential energy is the energy that is being built up at rest.
That is being built up at rest. Yeah.
So I want to ask a question. Uh, so mechanical energy is always constant. So it never changes.
Constant. Yeah, it won't change. From to the whole system, the mechanical energy will remain constant. Okay, it won't change. It won't go low. It won't go high. It will remain constant as me. So now I told you that the potential energy is related to the change in position because I am changing the height of this object. The potential energy is created. So potential energy formula is M into G into H, mgh, mgh. Okay, M here it is called as mass. G is acceleration due to gravity which is nearly around 9.8 meter per second. But if sometimes in the question, if it is given 10 meter per second square, you can take that also. Okay. And H is basically it's raises height, but in some case it can be, we can write change in position also. Change in position also. In some case, we can write change in position. And if I will talk about kinetic energy, it is equals to half mv square, where half is half, m is mass, and velocity is v. Got it, everyone? Now I will ask this question from David. David, if the velocity of the particle will be doubled, okay, because more energy, if the velocity of the particle is doubled, okay, then what will be impact on the kinetic energy?
Kinetic energy would also double.
Will also double. Okay. Aida?
Yeah. Yeah, it would double.
Double. Okay. Just round.
Yes, sir.
If the velocity of the particle is doubled, then what will it impact on the kinetic energy? Like we have this formula, half mv square. In this, if I will instead of v square, if I will write 2v square, 2v whole square, then what will be the answer? Kinetic energy.
I guess it would double.
Okay.
Me. Can I answer?
Miracle, what you will say?
I also guess it will be double.
It will be double. Okay, Agatha,
What was the question?
I'm saying that if the velocity of the particle is double, if it is double, then what will be impact on the kinetic energy?
I guess it also like increase.
Increases by what time? Double, triple.
Double.
Okay, double.
Me?
Okay, yeah, now I drink. You say.
Okay. So here it'll actually increase 4 times because 2 square is 4.
Yeah. Now everyone please pay attention. See, what I am trying to say, we know that now the new velocity is 2 times the old velocity. Yes or no? New velocity is 2 times the old velocity. So new kinetic energy formula will be half into m into v dash square. This is the formula for that. Everyone please pay attention. Are you getting this? Now instead of v dash, can I write 2v because both are equal? So ke dash is equals to half into m into 2v square. Yes. So if I will write like this, k dash is equals to half into 4 into mv square. Okay. I will not cut it. Why I'm not cutting it? I will say. So it will be like 4 into half into mv square. Now half mv square is equals to ke, the kinetic energy before. So it will become K dash, Ke dash is equals to 4 times of the Ke. So it means that we can conclude that if the velocity of the particle is double, the kinetic energy will increase by 4 times. Got it? So in the same times, whatever the velocity is increases, it will be the square of it. If it is 3 times, it will become 9 times. If it is 4 times, it becomes 16 times the kinetic energy will increase. Everyone got it? Agatha, Miracle?
Yes, sir. Got it.
Yeah.
In the same way, if the now I will ask this question from David. David, if the mass is increases by 2 times, what will be impact of kinetic energy?
So it will double this time. It will double.
It will double. Ira,
It will double.
it will double. Yes, Edric,
It will double.
it will double. Yeah, because in the mass it's not square. Okay, mass is like kinetic energy is not equals to the mass of that. So it will be double only. Everyone got this concept? Yes or no? Okay. So I request you guys to read this kinetic energy and this potential energy at home also. Okay, the paragraph you can read it at home. Now we can read this thermal energy. This is the form of energy which flows into our body to give us sensation of hotness and out of our body to give us sensation of coldness. So thermal energy is the energy that is related to the heat. Light energy. Light energy is the energy we learn this concave and convex, not with the new batch, but with the old batch we learn that. So this is all about the light energy. Electrical energy, we all did electrical energy in which the electrons move. Because of that electrons movement, the electrical energy means electricity flow. Perfect. Yes.
The heat produce that energy.
Sorry.
How does the heat produce that energy?
How does heat produces that energy? Which energy, beta?
The energy it's talking right here, thermal energy.
The thermal energy. Okay, for example, I have this bottle in front of me. Okay. Now, if I will put a hot water in it, because it's not a good insolution, it's a normal steel bottle. Okay. So what will happen after some time? The hot water will become cold. Okay, so it means that the hotness of that water, the temperature of that water, it cools down because the heat, the thermal energy is coming out of it. Got it?
Yes.
Or we can take one more example. If you will, if you will take out the ice cream packet from the freezer, then when you will take it out, there won't be any water droplets. Yeah. But if you will keep outside, then what you will find it out? The water droplets are forming near the packets. Why so? Because the air or near the packet become condensed, become from water vapor, it become to the water. Because of that, the thing is the water we see the water near the packet. So this is all related to thermal energy. Got it?
Yes, sir.
The example.
Yeah.
Well, I don't still quite understand about how does thermal so thermal energy is actually energy released by heat.
Yeah, which releases the heat.
Okay.
Whenever there is a flow of energy, it is called as thermal energy. Okay. Thermal energy is thermal energy is related to the thermal only, means the heat only. Whenever we will read about the heat energy, it is called as thermal energy. Okay, magnetic energy. Magnetic energy we all learn. Okay. Sound energy, the sound energy is the energy which enables us to hear. Okay. This is called as sound energy. And the nuclear energy is non-conventional form of energy which is released when the nuclear reaction happens. And because of that, a large amount of heat created, and we use it to make electricity, and we use it for making other purposes also. So we have all these types of energy. We did this. Now we have the next topic. It is called as energy transformation and conservation. So just for a introduction, I will teach you what is energy transformation. Okay, for example, two cars, they were on the road, and what happened? The both cars collided. Then the first thing, what will happen when the two cars will collide? Anybody?
Maybe the airbags will just come out like that.
Airbag that is inside the car. But as a viewer from outside, when you will see when two cars will collide, then what thing you will observe?
Like it will crash. The both cars will crash.
It will crash, okay. And
Sir, the
The
front
half
will
front.
get like crushed up a bit to like absorb the impact.
okay, they are crushed. Okay.
Like the front part of the car is full destroyed, and sometimes if it's very bad, then fire can happen like that.
Fire can happen. Okay. Anybody else? I'm not getting that answer which I'm looking for.
There will be like a noise, like a crash noise.
Yes, there will be a crash noise. And there will be the like as David said, there will be like damage in the car. So when the car was moving, they were in which energy? Kinetic energy, because they are in motion. And when they are in motion, when they came to each other, the sound will come. So it means that that kinetic energy is now converted into the sound energy. Or we can say that the kinetic energy is converted into deformation of that cars, which is also a part of mechanical energy. So it means that the energy cannot be created nor be destroyed, but it can transform to the another energy. Everyone got this? Like you can't create energy. For example, if you are burning a wood, you are thinking that I am creating a heat energy. No, the fuel, the wood is working as a fuel. You just give a strike, and because of that strike, now the wood is burning. It consuming the fuel of the wood. The fire is consuming the fuel of the wood, and because of that, the energy is transforming now. It's transformed into the light and the heat energy. So you can't create the energy. You can't destroy the energy. The energy cannot be created nor be destroyed. Okay, it can transform. It can transform. Everyone got this?
Yes,
So
sir.
we
So
can transport. So we can transport energy.
transport
I mean
or
transfer.
transform. Yeah, we can transform energy. Like for
Transform.
example, yeah. For example, the gym freaks, what they do? They took dumbbell or high weight lifting to lift up the not dumbbell, sorry, what was it? Dumbbells. Okay. So they are doing the potential energy, okay, like doing this. They are doing that. Okay. Potential with the kinetic energy means because it's in motion. So what will happen? They have their muscular energy. They are creating their muscles. So this all energy can transform. They won't be created nor be destroyed. Got it?
Yes,
So we
sir.
have
So
this yeah.
So energy can be transferred, not transformed, right?
Transform. I'm saying transform. I'm saying transform. Like sound energy can transform into the heat energy also. Heat energy can transform into the light energy also. Like that.
Okay.
Okay. Okay. So this is the law of conservation. You guys go through this page number. Okay. So this is in text 13.2 and the previous chapter, that question. Ira, the in-text question, that is all homework. Okay, and this in-text question 13.2, and you guys can read this page number 302.
So maths also index question.
The in-text question, the terminal exercise question, all this you guys have homework because we have weekend, Saturday, Sunday we have, so you guys can do. And then tomorrow, Monday, we'll complete this chapter also, I believe. Or can I do this part also? This chapter will also complete.
Okay, sir. Do it. Do it now.
I have to go out.
Okay, okay. Then we'll do on Monday. We'll do on Monday and we'll start the next chapter on Monday only. The next chapter will be anything physics will be left? No, no.
No.
We have the heredity. We'll go with the heredity. We'll go with the heredity chapter.
So last chapter in science is a biology chapter.
No, like 2 chapters are left, no, in science. Which 2 chapters?
Heredity and control coordination.
Control and coordination. We'll go with the heredity first. We'll go with the heredity and then we'll do control and coordination. So I guess we can complete the course by 9th March. So there won't be any problem. Okay, so you go read it. Ira, write all the homework that I gave. You guys can go and read it. And then Monday, if you have doubts, please come to me.
So
Yeah.
the index question 13.2, right? Index question.
Yeah, Ira will write it. Ira, you understood now?
Yeah,
Okay.
maths chapter 17 terminal exercise and index questions, and science index question 13.2.
2 and read it till the conservation of energy. Write that thing also.
Okay.
Okay, then I hope you enjoyed the class. Till then, bye. Have a nice day.